Okay, the second curve we're going to calculate the length of is the cycloid, right? The cycloid is, well, the curve is parameterized in this way, okay? What the curve look like is this. This is the cycloid, all right? Okay, and is the shape that is described by the cycle, right? Well, actually, it has to be a cycle of this diameter, so it has to go up to here. So you have a cycle, you describe a point in the cycle, and as the cycle is moving away, rotating, okay, in this direction, this point describes this curve. Okay, you got this, right? Well, I think at this point it should be probably this one. Okay, so this point here, as this is rotating and moving in this direction, okay, this cycle is rotating, okay, in this direction. This point here that you mark at the beginning and is on top, well, it's on the contact point with the floor, is describing this curve here. And it's called a cycloid, right? This is the parameterization of the cycloid, right? And we want to compute what is the length of this. So the position of the points of the cycloids is described by this vector t minus the sine of t, and y is a 1 minus cosine of t, right? And t runs from 0 to 2 pi. Okay, we need to calculate the derivative. The derivative of this is, well, a is a constant, right? So we can take it out. So the derivative of this is 1 minus the cosine. And the derivative of that is the sine. Okay? So if we calculate the length of this, well, the length square is equal to a squared times the square of this, 1 minus cosine t squared, plus the square of this, sine square of t. And if we expand this, we get a squared times 1 minus 2 cosine plus cosine square plus sine square. And remember the cosine square and sine square is equal to 1. So this is equal to 2a squared 1 minus cosine t. This is the length square, so the length is just the square root of this. So the length we want to calculate is the square root of 2 times a, the integral from 0 to 2 pi of the square root of 1 minus cosine of t. Okay, dt. Now, in order to get rid of this complicated expression, we need to use the formula of half at the angle and relate this to 2 times the square of the sine of t half, right? So if we introduce this here, we have a square root. With this square root makes 2, so 2a. And then we have the integral from 0 to 2 pi of the sine, well, actually of the absolute value of the sine of t half, because the sine can be positive or negative within this interval, and we just want it to be, well, actually no, because it's the sine of t half, and so this angle is going from 0 to pi, and in this angle the sine is positive, so we actually don't have here the sine, the absolute value. The sine is always larger than or equal to 0 within this interval, right? So what we have is 2a, and the primitive of that is minus the cosine of, well, is 2 times cosine of t half, right? Okay, that's the primitive, and we calculate the primitive between 0 and 2 pi. So what we have is 2 times a, well, minus 2, and then we have the cosine of pi, which is minus 1, minus the cosine of 0, which is 1. Okay, this is minus 2, So we have 8 times a, and that is the length of this cycloid.